Hi, welcome back to Science with Go. Today we're going to take a look at Lewis dot structures and talk a little bit about how these molecules are polar just by actually putting together their Lewis dot structures. We won't get into molecular geometry. Actually, that's beyond the scope of this class, but we'll take a look at just these simple binary molecular compounds, and we'll take a look at some larger ones too. But note that we won't get into bond angles and simple geometries for these molecules. We're just going to take a look at the Lewis dot structures and somehow predict whether or not they're going to be polar from that. All right, well, why don't we go ahead and look at water? We know, and it's best to actually just lay out these pieces. So like if you're playing with a jigsaw puzzle, you don't take a look at one piece and then go, well, I know exactly where that goes. You lay out all the pieces and try to figure out how they all sort of fit together. And that's what we're going to do right now. So we know that there's two hydrogens here, and each hydrogen, because it's in that first column under the main group elements, has one valence electron. We know that oxygen has 6, so let's go ahead and do that. And from class, I did mention that I wanted you guys to make sure that you box the lone pairs to understand that we don't actually form bonds with those anymore. We just have to go ahead and try to line up bonds with these unpaired electrons right here. Okay, so let me go ahead and erase that and redraw the dot right there. And this is a pretty simple molecule, so let's go ahead and line them up. Let's put one hydrogen over here on the left, connect that. Let's put one hydrogen down here at the bottom, put the single valence electron right there, and then connect those two. And there is the structure of water. Now let's have a discussion about whether this molecule is polar or not. Looking at the drawing that I just made, I can see that there is a higher concentration of electrons on this side of the molecule. If that's the case, that makes this molecule polar. And the reason why is those lone pairs are negatively charged. And if there's 2 of them, or 4 of them actually, total electrons on one side of the molecule versus the other, that makes this end of the molecule slightly negative over here. And that makes this end of the molecule slightly positive. Now you can say, well, Mr. Groh, what about this? What if I drew the water molecule in this way, where I had the hydrogens on opposite sides? Would this be nonpolar? And the answer is yes. If I actually drew it this way, the molecule would be nonpolar. But note that when we draw these Lewis dot structures and when we fill in the dots around oxygen, what we want to do is we want to make sure that we go in a either clockwise or counterclockwise direction, but we don't actually go back. So let me explain. What we do is this: 1, 2, 3, 4, 5, 6. Or what we could do is redraw the structure in such a way where we do the electron dots as this. I'll put it in green. 1, 2, 3, 4, 5, 6. And what that does is it kind of gives us a little bit of an order in which we label the Lewis dot diagrams. Okay? So again, we either fill the dots either clockwise or counterclockwise, but we always go in one direction, and we spread them out before we start to pair them up. All right, in the next lesson, we'll go ahead and take a look at another molecule that's polar as well, and or maybe nonpolar, depending on the example that we choose. And I'll see you in class.